Today I'm going to walk you guys through a very crude method of leveling out an X-axis gantry on a 3D printer that has dual Z-axis rods, but each Z rod is controlled with its own motor, so there's no timing belt system like you see on certain printers that do dual Zs. Now the problem is sometimes each motor can become out of sync over time. Usually that doesn't happen. The stepper motors are very accurate things, and in this case we have an Ender 3 with a splitter cable, so it's one signal being split to two motors, so they both get the same signal at the same time. And for me it's been quite reliable. However, once in a while you will need to re-level it. Usually you would just bring your gantry up, take a ruler, and you measure out something, let's just say 20 millimeters from the frame on the top on both sides, and you would twist each motor individually to get that. Now there's a much more crude method to doing this, and there's going to be some good debate as to whether or not you should even do this, but I have found that for a quick leveling setup, it works really well. And I am not by any means the first person to come up with this, but I have designed something for Ender 3s. Well, I'm sorry, remixed. I want to be clear, I remixed this for my Ender 3 over here as well as my friends, so that we could do that. And I call it a crash leveler. And it's because we're going to crash part of the gantry into these levelers to do that. Now, it works very simply. So this is one of those things. This is the crash leveler, and you print two of them out, and then you sand them to ensure that they are both the exact same height from the top and bottom, because that's what really matters. And then what I've done is, in the remix that I made it much longer, as well as I have a hole to put a screw and a T-nut so that it holds itself in place really well. And then the part that was original to this are the little slots that go into the extrusion. And once you measure it out and confirm that from the top of the frame these are both the exact same distance from each other, you now have a known point at which both parts of the frame are at a known level. So what we're going to do is I'm going to purposefully make this X-axis very askew. And we're going to do that by just taking one side, and we're going to lower it. And you can see, as I move this up and down, actually we're going to move this one up and that one down. So now you can see it's really askew. That would be a terribly level X-axis. But because we have these metal spacers here, and because they both measure the same point in height from the X-axis, what we can do is we can raise our gantry, and we're actually going to go back, and we're only going to raise it 1 millimeter at a time. And watch what happens, because one side is going to hit the crash leveler before the other, and it's going to stall the motor out to the point where it cannot go up anymore, and it's going to be the right side. You're going to hear the clicking of the motors. So if you hear that, that's because this side has crashed against the leveler. It cannot go up anymore. This side is almost there, but not quite. And we're going to keep doing this until both pieces, or both motors, get stalled in that top position. There, I can hear both of them now. So at that point we can go down, and now relative to the frame, the X-axis is actually level. It's a very quick and dirty way of doing it, but it is a way of doing it. Now, there is a right way and a wrong way to do this. The wrong way would be to have your V reference settings for the Z motors really high. You preferably want to set the VREF lower so that you're not forcing a bunch of electricity through the motors, providing unreasonable amounts of torque, because you are in fact stalling the motors out when doing this, or perhaps stalling is not the right word. You are forcing the motors to kind of bind and stick where they are once you crash the gantry on the levelers. So do be aware that you don't want to do that very often, but for a quick, dirty job, crash leveling is a real thing that does work, and I've actually found it works really well. But I only need to do this when I turn the machine off and turn it back on, or at least whenever I move, or at the most I should say, whenever I move the gantry without using the dial. Because if you move the gantry by hand, there's no guarantee that when you twist one motor, your other hand's twisting the other motor at the exact same rate. So that's when you would re-level it. But these machines are on almost 24/7 and printing almost 24/7. So the motors are usually synced pretty well. So it's only when you move the gantry by hand, or after a very long time, or when you turn the machine off and there's no power going to the stepper motors, that then they don't hold their position, that you would do this. So quick video, thought it'd be something worth sharing, and I will upload these things to Thingiverse as a remix to the original design, and I'll give a link to it in the description if you are interested. Fun note, I designed these to be extra long because we use bearing blocks to hold our Z-axis rods in place. We also have a BMG style extruder, which also takes up way more height than a standard extruder. So if we didn't have these extra long blocks, if we let it come up all the way up here where the stock, or the part that I'm remixing was, we would actually crash this extruder onto the bearing block before we would crash this spacer to the crash leveler. So that's why I designed it like this, and then, you know, screwing in with a T-nut makes it so that it stays in place properly. So there you have it. A quick and dirty way to level out your X-axis on a dual motor system.